Okay, hey, this is Math 2 Unit 6, Worksheet number 5, looking at dilations that are centered at the origin 0, 0 today. Okay, so we're going to decide if it's a reduction and enlargement first of all, and then graph the image given the dilation that's given. So first of all, we're doing a dilation of 2. That means we're going to be making this thing larger, so that's going to be an enlargement, okay, to begin with. And it helps here if we can find our origin, okay? So I'm going to put a dot right here where my origin is actually located at. So to enlarge this by 2, one of the easier ways to think about this is whatever I did initially on this one here, I went out 1, right? I went up 1 over 1 in terms of what I did. It went up 1 and I went over 1. And I'm going to do this by 2 now, so I'm going to multiply everything by 2. So instead of doing up 1 over 1, I'm going to do up 2 over 2, right? Because that's when I multiply that out, I get 2 over 2, up 2 over 2. And this becomes my, in this case, looks like an I, maybe it's an L, I'm not quite sure, I think it's an I. This becomes my I prime point right there. For B initially was going up 2, so we want to double that. Instead of 2, we do 2 times 2, so we're going to go up 1, 2, 3, 4, and that's where B prime will be located at. For M went down diagonally 1, so instead of going diagonally 1, we're going to go diagonally 2 for M prime. Here, and then Q went over 1 up 2, so we're going to double that. We're going to go over 1 up 2, and we'll do it again, over 1 up 2 more again, until we're right here. Okay, over 1 up 2, and yep, there we are. Notice that the length between Q prime and B prime is now 2, which is double what it was right there as well. Okay, the length here from Q to M, initially it was 3, I should have 6 now. 1, 2, 3, 4, 5, 6. So that one's correct right there. We draw our line right here for this one, and then we connect our dots here for this one. And that's what we get for number 1. Number 3 is a little different. We're going to have a dilation of 3/2, okay? Now 3/2, that is like 1.5, right? So it's going to be larger than the original. It's not times 1, it's times 1.5. So it's a half more basically is what we're talking about. So when I look at this first one here, I can see that, okay, my origin is here at 0, 0, no problem. And my G initially went over 2 and up 1. So now I want to do half of that again. So instead of going over 2, what's half of 2? Half of 2 is going to be 1. And instead of going up 1, I want to go what's half of 1, it's half. So I'm going to put a dot right there. So I've gone over 2 and 1 and then half of that, which is 1.5. Over here initially I went down, you can see here on this case here, I went down 2 and over 2. So I'm going to do half of that again, which would be down 1 and over 1. That's my half value, right? So half of 2 is 1. Here I initially went over 1 and up 1, 2, 3. So instead of going over 1 more, I want to go over half of 1, which is here. And instead of going up 3, half of 3 is going to be 1.5. So it's going to be located about here. So now when I connect my dots, I end up then drawing a line like so from here to here. This one's going to stay on that same line. And then I'm going to connect here to here, like so. And that becomes my new one. This again is an enlargement of the original. Okay? Number 5 down here, we have an example, and we have in our example it says that we have this shape and we're then going to that shape there. So the rule was x to y, and what's happening to the x and happening to the y. In this case, if we take a look here, we went from a length of 2 to a length of 1, 2, 3, 4. So our rule is we're doubling it. We're doing 2x. Our dilation is going to be a dilation of 2 in this case here. So for this one over here, what's happening is a little different. Okay, what we can see is that our initial is our x and our y. Okay, and starting at the origin spot, let's take a look here at where we are. That's our origin. Okay. And so initially our h length went out 1, 2, 3, right? It was 3 units long. Now though, it's only going to be 1.5. We went from 3 to 3.5 or 3 over 2. Okay, and so it is now 1.5. So we basically cut it in half, right? To go from 3 to 3 times a half means I'm doing half of what I had before. And that's what's happening there. So my relationship then is going to be half of x and half of y. And so our dilation rule in our case would be dilation of 1/2. And that's what's happening there. Again, this is all taking place from the origin. Let's take a look at the back side. Number 7. Again, our origin is where we want to start at here. And so there we are at the origin. And we see initially we have our x and our y, no big deal. And it's hard to read here a little bit, I know, but our x is the one on the inside. Okay, it's a smaller one where we're starting with. And so we're starting from the small one and we're going to be going out. So take a look here. Here I have a length initially from there to there of 1, 2, 3. And I go from 3 to adding in another 1.5. So I go 3 and I'm adding another 1.5. 1.5 is half of that. So again, my dilation is 3 over 2 like I did before. I'm increasing everything by 3 over 2. Okay, so if this length was 1, right, so 1, my new one is 1 times 3 over 2, which is 3 over 2, or 1.5. And where's it located at? 1.5. Okay, so that's going to be 3 over 2 x and 3 over 2 y for my rule right there. Let's take a look then at number 9 and 11. Okay, enlarge or reduce. If it's dilation of 2, we're going to be enlarging. 3.5 is greater than 1, so we're enlarging. 5 over 2, still greater than 1, we are enlarging. And 1/2 is going to be a reduction. Let's take a look at how we do this here. If my dilation is 3 over 2, what I can do with each point is I can take the point, -2, and multiply it by our dilation value. -2 times 3 over 2 is going to be reduced down to a -3. Okay, so I have -3, 0 times anything is still 0. 1 times 3 over 2 is 3 over 2. And then 2 times 3 over 2 is simply 3 for that one there. For the y value, it's 3 times 3 over 2, which is 9 over 2. And then -2 times 3 over 2 reduces down to a -3. So all we're doing is we're taking our initial value, or coordinate, and multiplying it by the new dilation value to find our new points. Okay? Same is true here for number 11, right? We take our -1 and multiply it by our 1/2, and we have -1/2. We take a -3 times a 1/2, and we have -3/2. We take a 0, and it's still 0. We take a -2, multiply it by 1/2, and we have a -1. We take a 3, multiply it by a 1/2, and we have 3/2. And we take a -5, multiply it by a 1/2, and we have -5 over 2, like so. All right, and that's the idea there. And let's finally take a look at our last one, number 13 together. Okay, and so we have 2 going to 0.5, 0 stays the same, 1 going to a quarter, right? So we're going from a 1 to a 0.25. Granted, it's negative. So basically going from 1, 0.25 is also going to be what? 1/4. So our rule here, we're reducing down from number 13, that's what we're looking at here, number 13, is going to be 1/4 x and 1/4 y. And that's our rule there. The same thing for 12 and 14, and you're good to go. That's it. We'll see you next time.